Hello everyone. Today I'm going to show you how to grab objects from a distance and have them held by the player as such. Objects that can be grabbed will be highlighted with an overlay when within range of the player. Pressing the grab button, the highlighted object will come to the player. If there's something in the way, the object is simulating physics, so the objects around it will be affected, but it won't block the movement of the grabbed object. The grabbed object is prevented from clipping through other actors and the terrain when being held. And if the object does get blocked from moving for any reason, the player drops it automatically if they move too far away from it. Okay, first things first, we're going to make a few objects for us to throw around, as well as a blueprint interface for us to get the information into our character's blueprint. So first we'll start off with a blueprint class of actor, and we'll call this BP object. We'll open that up, and we can add any static mesh we want. I'm going to add a cube, and I'm going to replace it with the fancy chamfer cube for the rounded edges. And then whatever mesh you choose, we want to make sure that that takes the place of the default root. Then we're going to take our third-person character and duplicate it and rename it BP enemy. And then we're going to make the interface. We'll just call it BPI underscore throwable. In the interface, we're going to set a new function, and it's just going to get a reference to whatever actors we want to have as throwable. So we'll say get throwable actors. And we'll add that as outputs. So we have our object that we can throw, which will be BP object. Then we'll have an enemy. Of BP enemy. And anything else that you want to throw, you can set to be a child of these objects. That way it will inherit the blueprint. But for now, we'll go back to our object, class settings, and then we'll add it to the implemented interfaces. And then we'll open up our BP enemy blueprint and do the same thing. Now in the interfaces, we'll double click on our get throwable actors, and whatever type of actor this is, we're just going to drag out and we'll get a reference to self. So our enemy is going to be our enemy and our object is going to be our object. And then we open up our third person character. Now the event that we're going to use to grab an object is going to base itself off of a trace. I'm just going to get this on event tick. And we're going to set a branch and promote this condition to a variable. And we'll just call it object grabbed. And make sure that it is set to false by default. So if we don't have an object to grab, we're going to be doing a sphere trace by channel. Our start is going to be our actor's location. And we want this to follow where we're looking, so we're going to get the follow camera and get its forward vector. And then multiply it a distance that you like. I'm going to say 600. And then add it to our actor's location. Now the only problem doing this is that this is going to face right through our character, so we're not going to see the trace unless we offset the Z value a little bit. So I'm just going to add 200. And our radius, we'll start off with 20. change the debug for 1 frame since it's going to fire off essentially every frame on tick. And so now when we start this though, you'll see that it's having this weird drift. That's because our camera boom is set to relative. So sometimes when we spin the mesh around, it's going to, well, swing the capsule component around, it's going to interfere with that. The rotation hardly matters in most situations. So if we set it to be a world rotation, we try again, we'll find that it is completely smooth. So on our trace, we're going to break the out hit. And we're only going to care about the actors that incorporate the interface. So off our hit actor, we'll get does object implement interface and select the interface that we made. And we're going to combine that with an AND bool for our return value. And it's up to you if you want to do this. We can set a distance to make sure that it's greater than a certain point. I'm going to say 100. Just because if we want to grab an object that is really close to us, we want to try to mitigate as many clipping issues as we can. So we'll get a branch. And if all this is true, then we're going to get our hit actor, and we're going to send a message to our interface. So we'll get throwable actors message. And since this message is agnostic about what actor we're sending, we're going to have to do a validation check. So we can get is valid, get the one with the white question mark. We'll check object first. If object is valid, then we are going to promote that to a variable. Set that to be our throwable object. If it's not valid, then we'll check to see our enemy. And if our enemy is valid, we'll promote that to a variable. And that will be our throwable enemy. So we'll put some of these into the map. We'll put one enemy in. And I'll stack up a couple objects. And actually off of our object, we're going to take our cube. And we want to make sure that simulate physics is on. So that way, that cube, if we run into it, we can push it over. Similar third person character, we're just going to get a print for our debug. So if I highlight an enemy, you'll see that it does not hit enemy because there's a few collision channels we need to change, but we will do so for the objects. For our enemy, we need to go to the mesh and check the collision there. You see visibility is not set to true, so we want to just change it from character mesh to custom and then back to visibility. And when we test it out, we can get a trace on our enemy actor. And while that's good, we want to be able to have some method in game to show the player that they are highlighting an object, it is in range, and they can grab it. So we're going to go back to our blueprint interface. We're going to add a function, and it's just going to call change material. It's going to have one input of type Boolean, and it's going to be called highlight. So now we'll go back to our object, and we'll double click change material. and we'll get a Boolean. Now, I have already made a highlighted material. If you want to download that, you can just get it from the description if you want to use an overlay. Otherwise, you could just change the material or add a Niagara effect. Choice is up to you. I'm going to set overlay material, or again, you could just set material. I'm going to choose it to be the material instance. And otherwise, we're going to set overlay material again, this time leaving it blank. So then if it's false, we can clear whatever's there. So back in the third person character, for our throwable object, call change material, message, and click highlight. If you are using an overlay, if we go to the cube, we need to disallow nanite. Otherwise, the overlay is not going to appear on the object. After we do, however, and we mouse over it, we are setting the objects to be highlighted. Now we need to set it so then when we are not overlapping with it, it will turn that overlay off. And we also need to add it to our BP enemy. At least with BP enemy, we'll just copy what we have here. Go to our enemy blueprint and then change material. Then we paste this in. And we'll remove the cube and instead add the mesh. Right, and then we need to go to our third person character and we'll just duplicate this, change material, and connect it to our throwable enemy. And now we have a highlight around our enemy actor. So there's two things we want to do before we get our throwable actors. The first is a do once. As we do not need to constantly update this on tick if we don't have an object in hand. And second, we're going to check to see if our other actor that we hit is going to be the same actor as what we have selected in these two variables for a throwable object or our enemy. If we highlight a new object before we assign that actor into those variables, we're going to clear the materials from the previous actor. Very simply, we're going to get our BP object, our BP enemy, and we're going to get an equal operator for both of these. And we're going to check to see if either of them are equal to our stored variables. Then we'll get an OR. Followed by another branch. I'm going to collapse these down to a node to save some space. We'll just label it check if new actor. So after we check for our actors, we'll change the material. Get the message, and we're going to collapse this down to a node to save some space. And we'll just say check material. And we'll drag the false branch in, as well as the top of the execute for the do once. In our branch, if our actor did change, then we're going to reset this, which will allow the next tick to run through and then close off the do once. In our check material, we're going to have to do this twice. The first time, we're going to take our throwable object and convert it to a validated get. If it's valid, we change the material. Otherwise, we'll check again for our throwable enemy. And then the first time we run this through, both of these are going to be not valid, so we just need to attach it to the output there. So in order for that to work, we also need to have something coming off of our false branch here. So then when we move our trace away from an object and we miss, we're essentially going to do the same thing. We're going to take our object, get a validated get. We're going to change the material if it's true. And then we want to get rid of our throwable object reference in our variable. So we're going to set it to none. Then we do the same thing with the throwable enemy. And if any of these checks are invalid, then we just go on to the end. And we want a way to reset this manually as well, so then when we go off of an object, we can reset this. So we're going to create a custom event, and we're going to call it reset actors. And off of the not valid for our throwable enemy, we'll just go there. So now when we check this, when we highlight an object and move away, we clear it. And if we're not moved away, because we're checking to see if the object that we had prior is the same object that we have in memory, it switches off when that turns out to be false. And of course, if we are too close to the object, it doesn't highlight it because our first check requires us to be at a distance of 100 units away. Okay, so now that we finally have the selection done, now we can grab our object. So I'm going to get a keyboard event and just bind it to F. And we're going to set our object grabbed to be true. We're then going to start a timer. Create a custom event off the timer. I'm going to call it move object to hand. Set it to be looping at 0.005 seconds, so it's relatively smooth. And we're going to add a scene component to our actor that we want to have this object be moved to. I'm going to choose a little bit to the right and barely above head level for the scene. I'm just going to leave it named scene for now. And we are going to set the actor location for our throwable object. So setting our actor location of our throwable object, we're going to get a vinterp. We're going to get our throwable object and get the actor location. And the target is going to be the world location of our scene. We're going to set the delta time to 0.1 seconds and the interp speed at 0.5. You can adjust as you'd like. It'll connect our actor location. And we'll just give this a quick run. So as you can see, since we're simulating the physics, it is doing exactly that. So when we get to our location, we're going to want to have gravity disabled so then it can just kind of float there. The timer is still going to loop, so then every time we move, the throwable object is going to stay very close to us. So we're going to take the actor location, get an equals equal, and we'll get the scene as well. We'll say at a distance of 50 units. We're going to take our throwable object, and we're going to set gravity enabled. It will automatically add the cube, and we'll just leave it unchecked. So now it's no longer going to be doing that. We'll fix the camera in a few minutes. Actually, I'm just going to take the scale of our cube and bump it down to 0.8 on each side, so they're just a little smaller. So if you do not want to have that cube spinning as often as it does, we can go to the cube and the blueprint, and we can look up dampening. And this angular dampening is going to be what controls the drag force on the rotation. It is pretty sensitive, but if we set it to 25 and try again, it does not move nearly as much as it would. And if we wanted to have better control over this, we could take our throwable object and cube, and when we grab it, we're just going to get simulate physics and just briefly turn it off. Then we can copy this, and at the end, when we get to our location, we'll set it to be true again, because we need to have it true when we activate gravity, otherwise it's not going to work. And this leads us to one more issue that we want to check out. If we grab an object and we try to move it through, you'll see that it has like this shuddering as the object is partially going in. So we would want to check sweeping on our actor location, and we might also want to have teleport as well. But if we have sweep and we try to move this, it's not going to move because it's impacting something, and so it's not going to go to us. We can turn sweep on after we get to this point. So we're going to create a new Boolean, and we're just going to call it primed. Then we're going to plug it into our sweep. So primed is going to be true when we reach the destination of our scene, or close enough to it. Then we can start sweeping the location. So now it is doing this behavior of going around and just otherwise trying to get back to its position. Now we do have this opened, so if we do press F while we don't have a throwable object, it's going to give us a lot of errors, so we're just going to have a validated get. And if that's true, then we can set the simulation off of our cube here. And another thing that we can do is check to see if our object is caught if we get too far away. Because right now it will keep forever, and then if we get within range, it's going to snap back to us. So we'll get another branch after this sweep. And we're going to check to see if this is not Boolean. So if our return value is false, and then we'll get distance 2. Another actor being our throwable object. I'm just going to collapse this all to a node to save space again. We're just going to call it distance check. We'll check to see if our distance is 500 units away. And if our sweep results are false. And we don't need to have this be either primed or unprimed. This is a check that only needs to happen once. So we're going to get a do once. Then we're going to create a custom event to reset our priming. Connect to our reset. And now we need to have an event for us to drop the object, which is basically just stopping this timer and changing our simulation back. So we're going to create another custom event and call it drop object. We're going to take our timer and promote the handle to a variable. And we'll call it object hold timer. And then we'll clear and invalidate timer by handle. We'll set primed to be false. We'll copy our simulated physics and gravity and set both of them to be true. We'll take our object grab, set that to be false, so then we can select another object again, and then we need to reset our priming. And we can call it dropped object. Actually, as I look at this, we'll need to just swap this branch with the do ones, because we don't want to just do one check, we want to do multiple. Now when we test this out, and we get it caught on an object, we go too far away, we drop it. So now on our input, take our F, and we're going to get another branch. And we're just going to check to see whether or not the object is primed. So if the object is, I'm just going to not bool. If it's not primed, then we can start. Otherwise, if it is primed, then when we press F, we're going to drop the object. So now when we go and do our grab, if we press F again, we drop it. If we're too far away, we still drop it. And the last thing we want to fix is this camera, because we don't want this object to get in the way of our spring arm component. So when we press F and we have our cube, we could set collision response to channel. And the channel for our camera we'll set to ignore. So now when we grab it, our camera is going to do exactly what we set it to do. And then at the end of it, when we drop it, we could set it back to block, and you could set that as a delay if that's what you'd like to do. So then it drops a little bit before it returns the camera collision back. And finally, we're going to be addressing one other issue, which is if we can angle it right, there's a possibility for us to do this. Normally we'd be able to detect this with sweep hit results, but since we're bringing an object to our scene component, sweeping is disabled. So we're going to need to make use of our blueprint interface to send some information back and forth between our object and our third-person character. So we'll create a new function and we'll call it interrupted. Back in our object, we could take our highlighted value and promote it to a variable. Because if the object is highlighted, we know that it's the object that's currently in use. Then we'll add a box collision. And off of the component begin overlap, we'll first check to see, is our object highlighted? Next, we'll check to see, is our other actor in our collision equal to our third-person character? We could just get player character. If it is, we're going to send an interrupted message to our third-person character. In our third-person character, we'll now add the interface. You can also do this in an interaction interface if you already have one. So we'll double-click on interrupted and drag that over to any portion where we have our dropped object. And now we want to check to see if this is interacting with our character if we're not primed, because if we bump into it while we're holding it, we don't want to drop it. So if we're not primed, then we will go. And then finally back into our BP object. We'll drag off of our player get and send a message for interrupted. So now if we test this out, it'll still shift around us, but we should be able to, right. It will stop if we're standing on top of it, but we may have to make some adjustments because if we have our side turned, it will run into us on our opposite side and we won't be able to pick it up. So we're just going to get a delay. We'll start it off with half a second. And then we're just going to check again to see if this case is still true. So now it interacts with us, may be able to go through us because we don't have it sweeping when we don't have it primed. And we can only get so far. And we can adjust that timer as we see fit. If you have a more elegant solution to this, let me know in the comments. It's kind of one of those things that it's just the nature of the beast. There's not too much we can do without getting very crazy with a bunch of other line traces. And it's pretty hard to replicate anyway. But hey, if someone is going to run your game in a speedrun, you can bet that that's going to be taken advantage of. And one more stopgap measure to help performance. At the end of our grab, we'll take our cube and we'll set the linear dampening to something high to match what we set the rotation for. Say 25. This will ensure that if we bump up against the object or the object bumps up against us while we're moving, it's not going to simulate physics so hard that it tries to escape the pull of our interpolation. And then we'll go to our dropout event, and right after we enable gravity, we'll set the linear dampening back to its default of 0.01. So that's the first part done, and in the next part I'll be going through 3 options for throwing the object at our enemy character, including collisions, homing, dealing damage, knocking down the target, and a bit more. So thank you for the patrons for voting on this for the December tutorial poll, and a special shout out to the pillars of the community for their continued support: Winterberry Shark, Francesco Pota, and K Panic. And as always, I ask that you like the video if you did indeed like the video, and subscribe for part 2, or if you like project tutorials such as this. So thank you all for watching, and I hope you've been inspired.